Okay, so just want to do a quick video here. I had some questions with regard to how to set up and then later adjust the front brake, the front twin leading shoe brakes. So I just wanted to make some comments. When I went and reviewed my videos, and I talked about making sure that the actuating levers for the brakes were in parallel to each other, that basically formed a parallelogram. And I just want to kind of illustrate it a bit. I've got the brake on the bike, so I'm not going to take it off the bike. Instead, I've got some diagrams here, and we'll just refer to the diagrams, but this is essentially what we have inside the Enfield brake, inside the Bullet brake. So you got the two shoes, and you've got the pivot points, and then the cams. So these cams will rotate as the brake levers pull, or brake arms pull on, rotate these. And they'll push the shoes out. This one will go out this way, this one will go out that way, and they'll kind of contact, well, they will contact the drum, the inside of the drum. You want this to happen absolutely evenly, so you want the same force applied to the bottom cam as you have to the top cam, and so that they not only the same force but the same distance. They need to rotate exactly the same, so that you don't end up having the one brake shoe contact sooner or with more force than the other brake shoe. What you'll end up with in a hurry is you'll end up with one brake shoe glazed and the other one not properly contacting the drum, and it'll just be uneven. You won't get the best efficiency out of your braking, and you'll actually start to move the whole plate off to the side. And I kind of discussed that earlier in one of the other parts, the other videos that I had about the front brake, when I talked about the center nut not really working well for me, and I ended up with a cracked mudguard stay because of the uneven braking forces that had been applied to the mudguard stay. So since then, I haven't, since I've changed how I had the brakes set up, and I didn't have that brake, that was the way that they were set up from the factory. They were wrong from the factory, but I've set them up in this manner, and since then I haven't had any problems, and the brake is definitely, even though it's got new shoes, it's definitely a much more strong brake when I pull in on the lever. Okay, so that's what they look like on the inside. So now what I did was I kind of took a similar diagram, and I made some just some lines overlaying the interior. So you just have to imagine that the brake cover is brake plate is on now, and here I've got the short upper actuating arm and the longer lower actuating arm, and that's the one that the cable from the front handle, or the front brake handle on the bars, comes from and acts on. So if you look at this, and let me just kind of rotate you guys down a little bit so you get a better angle on this. I'll just kind of pull this in here. So I'll get rid of that one. So what you got here now is you've got these two actuating arms need to be absolutely parallel. If they are not parallel, if the ends are closer than they should be, closer together than parallel, or further apart than parallel, what you're going to end up with is when you pull on the handle, brake lever, and you pulls up the brake cable, it's not going to move evenly on these two cams. And that's exactly what you'll end up with. What I mentioned before, you'll end up with uneven force being applied on these two drums. So these two have to be absolutely parallel. So on my bike, when I measured the distance between these two, the centers of these two cams, because remember, these come through the brake plate, and that's what you attach the arms onto, and then the nuts go on there to just hold them in place. When I measured those, it came out to, and it still does, it comes out to 145 millimeters exactly. So what you want to do is you want to adjust this rod so that these two arms are in the center of those dowels where the arm pivots is exactly 145 millimeters. And that way you know that you've created a parallelogram, and any force applied to these arms as they I guess they'll move down this way because this lower arm will be pulled up in this direction. Any force that's pulling down on this will be absolutely even, and will apply even force on both of force and distance on both of the distance of rotation on both of those cams. Make sure that those are parallel. That's the absolute key. The other thing that I did, and it was interesting because I went back and I looked at some old photographs of my bike that I'd some close-up pictures of my bike I'd taken from years gone by. When it was the original factory setup with the original brake shoes and that, before I did all this work on the front brake. And what I found was that this lower arm was actually almost in line straight across this pivot, and that's incorrect. You want to install these arms so that this arm is just a little bit lower than if it were exactly in line with the center point of that cam. And here's why. As this pulls up, as this brake cable pulls up, when it's here, if you get past 90 degrees on this, and you can see the angle. Oh, let me see. You can see that the angle made here is less than 90 degrees. And as you pull up, this starts to go up and it becomes more and more 90 degrees. If you go past 90 degrees on this point here, you're going to start to reduce your efficiency, your mechanical efficiency. So just a few degrees down, I don't know what this angle is, say 85 or 83 degrees. Like, you don't have to get crazy about measuring the angle. You can do it by eye, because this doesn't move much. It moves just a little bit. It just moves a little bit to fully engage the brake. But you want it to be, this angle here, to be less than 90 degrees. And that way when you pull up, you're getting the maximum torque applied onto those two cams, and the maximum torque will be the maximum amount of efficiency that you're pushing against those shoes with on the inside. So that's it. I mean, basically this is two levers, the bottom lever and the top lever, acting on these cams that push out the brake shoes inside. Keep those parallel, and then just drop this one down a little bit so that this angle is less than 90 degrees, and it doesn't go past 90 degrees when the cable is fully pulled up, and you'll be good to go. So that's that one. So now let me just kind of flip you guys up a little bit, and I'm going to go over to the actual brake, and we'll just talk about the adjustment, because that was another question that I got about the adjustment. So all I did was, once I put the cable back into the bottom here, and this was all slack, right? You'll have slackened this off. You put it in, and I just started tightening it. Now you can tighten up by the brake handle, brake lever up on the handlebar, but I did my adjusting, most of my adjusting here. So just back off this lock nut, and then just start screwing this out so that it goes up, pushes on the brake cable housing, and that'll pull on the whole setup here, and pull on the cable. You can see how I have mine. I got it a little bit loose. I don't want it to be super tight. I want a little bit of slack before the brake engages. I like having it so that my brake doesn't drag. And when you set this up, as you're adjusting it, it'll end up pulling up a little bit. I have the front end of the bike off the ground, jacked up off the ground. I just put a jack underneath the engine mount there, the front engine mount. I'll just put a jack there and lift it up. And I just turn the wheel by hand slowly as I adjust this cable to tighter and tighter and tighter. And you'll hear the brake shoes start to drag inside the drum. And when they do, you can just back off a little bit, and that's where I set it. I set it so that the front wheel turns freely, and I'll just give you an idea. You can see for yourself, right? That is from slack to pretty well fully engaged. Like it moves just a few millimeters. It doesn't move very much, maybe 4 or 5 millimeters. But that's all it takes, because you get the whole arm here, you get the whole lever a little bit of movement here is quite a, is all the power goes into the shorter arm here. And anyway, so I'm hoping that that helps straighten things out a little bit, and